I understand that some of you may have some questions on a few of them. Some of you talked to me briefly yesterday and said that some of the ones towards the end were giving you difficulty. So number 27 says x equals 10. I hope we realize that's rectangular and we want to try and get what that would be in polar. We know that x equals r cosine of theta and y equals r sine of theta. And so what we can do is we can replace this x with r cosine of theta, and then the 10 just stays. And that would be fairly acceptable, except r equals is better, especially if you want to try and graph it. And so then this cosine's got to go. And the only way, I got to move the cosine and the angle, theta. And so what we're going to do is basically divide by cosine of theta. It's not arc cosine because I'm not separating the angle from the trig. And so r would equal 10 over cosine of theta. Acceptable answer, but it can get a little bit better because really this is saying take 10 times 1 over cosine of theta, 10 over 1. And 1 over cosine of theta is secant. So r equals 10 times basically 1 over cosine, which again is secant of theta. That's in case you were looking in the back of the book and you were wondering where r equaling 10 secant of theta came from. So that's probably the best answer. This is obviously acceptable, and technically back here at this spot, it was a polar equation, just probably not in the best form. It's not just r equals. Okay. And 29. This one's probably a little bit more complicated because there's more variables in this one. Many different ways you could have gone about this one. You could do this very similar to the one that we did in class yesterday where we replaced x, replaced y, but it just makes more work for yourself. Really, this particular y right here, I would say we don't have a whole lot of choice, but what we could do is take a 2 out, factor it out, and then we're left with x squared plus y squared equals 5y. And if you remember, we noticed that r equals the square root of x squared plus y squared yesterday. This is the one that somebody in each class noticed, hey, wait a minute, if we have x squared plus y squared, well, if I just sit here and square both sides, well, isn't r squared going to equal x squared plus y squared? And you could look at it that way if you want. It's probably the quickest way. So then all of this can get replaced with r squared. So it's 2r squared equals, but we don't have the luxury on that side. We can't. We have to just replace y with what we know it to be. And so you notice here I'm kind of using both sides of your notes. You don't necessarily have to stick with just one side. We know that y is r sine of theta. So r sine of theta. Once again, I'm looking at this and I'm saying, well, wait a minute, we don't have kind of r by itself. So one thing you could do is obviously then divide by the 2. So this would all be divided by 2. So then that's gone. And then if you're looking at this r squared and say, boy, we should take the square root of both sides. Well, you could do that, but if you looked in the back of the book, that's definitely not what they did. They don't have a square root there. What they did basically said, okay, well, if I got an r squared here, well, that's good. They said, but I don't really want an r there. So let's divide both sides by r. If I divide this side by r, it cancels. Divide that side by r, it cancels with one of them. So r equals, and they probably wrote it as 5 halves, this 5 divided by 2, and then sine of theta. And that's probably one of the easier ways of getting that one done. And you obviously could have just replaced the x with r cosine of theta, replaced that with r sine of theta. It would just would have taken a little bit longer, would have gotten to that cosine squared plus sine squared we did yesterday, which is just 1. And it would have ended up being very similar. Okay? So that's probably the best answer for that one. It gets r by itself. Okay, if 29 it wasn't the hardest, then 31 very well could have been. But you had to put a lot of information together here. First thing I would do is figure out, well, what does that really look like? And if we had a whole bunch of circles here for polar, we know that negative 45 would be right here. And so basically would be this line is what we would graph. Well, graphing lines isn't too hard in rectangular, but getting from polar to rectangular is. Some of you may recognize that as a line that we have graphed before. It is y equals negative x, because whatever x is, y is the opposite of that, and so that's why it works out that way. But getting there is a little bit harder. But what they're talking about is really this side of it. So I think we could agree that the x value is positive. So we would do the one where x is greater than 0 is the one we would focus on. And that says to take the arctan of y, wow, that's a terrible y, over x. There's no need to add pi here because we're dealing with basically the first, well, basically the fourth quadrant. And so we don't have to add the pi to get to either the second or the third. And so we would replace, because that's what theta equals. So we can replace theta with the arctan of y over x equals negative 45 degrees. And now what we would need to do is, well, we don't want arctan there, so we have to figure out what's going to cancel out arctan. So I wanted to see, and this reason I didn't really give you one like this is I wanted to see if you would figure that out. You could always look at your calculator. Arctan, the one thing that will cancel it out is if I take tangent of both sides. Because arctangent and tangent are opposites. So I have to take tangent of negative 45. And that's something that I think that we should be able to take care of. And hopefully it doesn't take you too long to figure that out. Because if we are sitting right there, we are talking about square root of 2 over 2, and then negative square root of 2 over 2. If you take sine over cosine there, you basically get negative 1. So y over x equals negative 1. Multiply both sides by x. These cancel. Y equals negative x. Again, I left that one out there to see if you would know that tangent would cancel out the arctangent and know which of the thetas to use. Really, you would have been fine either way, would have worked out. But if we are having x being positive, it is talking first and fourth quadrant. We were looking at fourth quadrant because that's where negative 45 degrees would be just on itself. And so that's why we would choose x being greater than 0. Okay. And that was number 31. Sorry about that, I didn't write it up there. And number 33. R equals negative 2 secant of theta. Well, now that you saw one earlier, you might have some idea of what you might want to do here. You could replace r with the square root of x squared plus y squared. I don't believe that to be the best option. What I would do is look at it as this saying negative 2 over 1 times secant, or in other words, times 1 over cosine. And so what I would do is multiply both sides by cosine. So if I multiply this side by cosine, multiply that side by cosine, gone. So it's r cosine of theta equals negative 2, and r cosine of theta is known as x. So x equals negative 2. That one was a little harder to see. It wasn't a hard problem, but it was probably harder to see. But hopefully once you saw number 27, how they manipulated that, you could see how we could come to that answer. Were these easy? No. You had to work at it. But it would be pretty clever if you went with the square root of x squared plus y squared. It just, you don't really get anywhere. Hopefully that clears things up for you.